Hello and welcome to this third video in a series introducing carbon-based compounds. Now this one is a little less introductory than the ones we've had so far, and if you're doing National 5 chemistry or its international equivalents, you may well not need it. So if you want to skip this video, fine, I won't feel at all offended, but you may want to watch it just for interest anyway. Hello and welcome to this third video in a series introducing carbon-based chemistry. Now this one is a little less introductory than the previous two, and if you are doing National 4 chemistry in Scotland or its international equivalents, you may not need it. So don't feel you have to watch it, I won't feel at all offended, but you may find it useful. Okay, what you should already know. You should understand the term hydrocarbon. A hydrocarbon, remember, is a compound made of hydrogen and carbon only. You should be aware of the alkanes. This is a group of hydrocarbons with general formula CnH2n plus 2. In other words, however many carbon atoms you've got in a molecule, you'll have twice as many hydrogens plus 2. You should know that alkanes are saturated. That means all the bonds in the molecule are single bonds only. You should now also be aware of alkenes. Alkenes have a general formula of CnH2n. So however many carbon atoms you've got in a molecule, there'll be twice as many hydrogens. Now these are unsaturated. They contain a double bond. Now I've put that in inverted commas because unsaturation could also mean having a triple bond or more than one double bond. But for alkenes, we are dealing with just one double bond in the molecule. Okay, now we're going to move on to cycloalkanes. Consider that. That's propane, right? 3 carbons, 8 hydrogens, formula C3H8. And it is saturated. All the bonds are single bonds. Notice you've only got one line between each pair of atoms. Okay, now let's throw that hydrogen away. And let's throw that hydrogen away. Like we did when we were looking at how we could think about alkenes. Now, that carbon there now has a problem. It should be bonded onto something else. It's only got 3 bonds. That carbon has the same problem. Ignore the fact I've left that line in. That carbon needs something else to bond onto. Now in alkenes, we saw that could form a double bond. But that can't happen here because these 2 carbons are not next to each other. But what if we could bend the molecule round so that those 2 carbons joined up down here? What we'd get is something like this. Yeah, I know, mind blown, eh? Now notice this has 3 carbons, as before, but only 6 hydrogens. So the formula now is C3H6. And we can't call it propane because it's not propane. We're going to call this cyclopropane. Cyclo means the carbon atoms are arranged in a ring. Notice though, it's still saturated. There are only single bonds in this molecule. Each pair of atoms is joined by only a single shared pair of electrons. Okay, let's be able to name these now. Now once again, you've got this table of prefixes. You should be familiar with it now. Notice once again though, we will not need that prefix there because you can't have a ring of carbon atoms if you've only got one carbon atom. In fact, you can't have a ring of carbon atoms if you've only got 2. So we're not going to need that one either. Okay, so let's consider cyclobutane. Look at that name. See what it's telling us. The bute means there's 4 carbons. The cyclo means those 4 carbons are arranged in a ring. That then is cyclobutane. Formula C4H8. 4 carbons, 8 hydrogens. Now notice for every carbon there are 2 hydrogens. Okay, what about cyclohexane? Well, The hex means there are 6 carbons. The cyclo means they're arranged in a ring. There we are, cyclohexane. Formula C6H12. Again, notice for every carbon there's 2 hydrogens. The number of hydrogens is double the number of carbons. So our general formula is going to be CnH2n. But wait a minute, you may say, isn't that the general formula for alkenes? Yes, it is. And that leads us to the idea of isomers. Consider this. Look at that formula there, C5H10. Now what could that be? Well, it could be this. It could be pentene. Notice 5 carbons, 10 hydrogens. Count them if you don't trust me. Notice it's got a double bond, so it's unsaturated. This is pentene. But it could, that molecule C5H10 could also be this. That is cyclopentane. Notice, again, 5 carbons, 10 hydrogens. That's why it's C5H10. This time, though, that molecule is saturated. It is a cycloalkane. So these 2 compounds have the same chemical formula, C5H10, but different structures. They are said to be isomers of each other. Compounds with the same chemical formula but different structures are isomers of each other. What this tells us is that for every cycloalkane, there's an isomeric alkene. So for every cycloalkane, there's an alkene with the same chemical formula but a different structure. There is, by the way, one alkene for which there is not a cycloalkane isomer, and I'll leave you to work out what that one is. Okay, so what have we covered? We've introduced cycloalkanes. We've seen that these are still hydrocarbons, but the carbon atoms are arranged in a ring. They are saturated compounds. That means you've only got single bonds in the molecule. And their general formula is CnH2n, the same general formula as the alkenes. That's why we needed to introduce the idea of isomers. That isomers are compounds with the same chemical formula but different structures. As we saw, for example, C5H10 could be either pentene or it could be cyclopentane. That's all for now. Thanks for watching. Goodbye.